This is problem 5 of Unit 4. Unit 4 review. Okay, so it looks like from this we're playing a game. So and they want us to find the mean and standard deviation. So I think we're going to need a probability model for this game. So I'm just going to say, be kind of boring, my random variable is going to be x, and the probability of x is going to be p of x. So you have to pay $5 to play the game. So there's a 10% chance of winning $5, but you have to pay $5. So that's going to be 0. Okay, and then there's a 40% chance of winning $7, so that's going to be $2. And then there's a 50% chance of winning $3, but 3 minus 5 is -2. Okay, so this is the probability model. Now to find the expected value, that's going to be the sum of each outcome times the probability of the outcome. So that's going to be 0 times 0.10 plus 2 times 0.40 minus, well, you could say, yeah, plus a minus, but minus $2 times 0.50. And that comes to negative 20 cents. Okay, so now to find the standard deviation, which is what they are asking, you first have to work with the variance. So you could write, the Greek letter is variance, or sigma squared, and we write variance of x. So you don't have to write both, but you should use one or the other. That's going to be the sum of each outcome, and we're going to subtract off the expected value, square that difference, and times it by the probability of the outcome. That's going to be the variance. So it would be 0, oops, it's going to be 0 minus a negative 0.2. So be careful. And we're going to square that times 0.10 plus 2 minus a minus 0.2 squared times 0.4 plus -2 minus minus 0.2 squared times 0.50. So you may have to clean this up a little bit before you put it into the calculator. Obviously this is going to be a positive 0.2 squared times 0.1 plus this is going to be 2.2 squared times 0.4, and that's going to be a negative 1.8 squared times 0.5. Okay, so you have to put that into the calculator, and I get 3.56. So then the standard deviation of x, SD, of x is the square root of 3.56. And that comes out to be 1.89. Okay, so that's the first, that's A. What about B? You play twice, assuming the plays are independent. So that means we can add the variances. Okay, so B is we just play the game twice. So what do we expect to make? So we play it once, and then we play it again. So the event happens twice. So that's just the expected value of x plus the expected value of x. So that's going to be negative 0.20 plus or minus a negative 0.20. So not a very smart thing to do. Okay, and then that's expected value. So the variance of x1 plus x2 is just going to be the variance of x plus the variance of x, or 2 times the variance of x. And we already have the variance somewhere. Where is it? 3.5. Okay, and so anyway, I guess I could say the standard deviation of x1 plus x2 is the square root of 2 times 3.56. And I don't think I did that yet, so let's just see. Clear. I'm not quite sure how to use this calculator. 2 times 3.56. So that's going to be the square root of 7.12. And okay, there it is. So 2.67 dollars. That's an interesting swing. So that's why people would play the game. I don't know if you see that or not, but they may play the game twice and occasionally they win a little bit of money. If they keep playing it over the long haul, they're going to lose. Okay, but that's, in any event, that's how you answer those questions. So just remember, when you add 2 random variables to find a standard deviation, you have to work with the variances and you add the variances. Good luck.